All right. Our presenter tonight really needs no introduction, but here we go. Jim got his amateur license in 2021, but his journey in radio started with CB at the age of 11. Beyond the locals in town, Slim Jim made contact, Slim Jim, I like that, made contact with operators in neighboring states, which led him to a long wire out the window, antenna wire out the window. Cell phones gradually took over, but in college, he took up the shortwave listening hobby and listened to the world from his dorm room. He is now an extra-class ham operator with antennas all over his yard, talking on HF just about every day. He also works at the local candy store, HRO, where he helps others out with their radio-related questions all week long, and he does a good job of that. Aside from ham radio, he also enjoys computer programming, networking, music composition, and spending time with his family in the great outdoors away from the hustle and bustle of city life. And so with that, I introduce Jim, W6JCZ, right?
All right, good evening, everyone, and thanks for coming to the presentation for the night. So with the California QSO Party hot on the heels of everyone's minds, I decided to give a little presentation on how you can optimize your HF reception. So here is a screenshot I just took one night on my HF radio, and there's a lot of things on the screen here. You got things like NR, Notch, BC, EQ, TX, BPF, all these acronyms, all these functions that you may be going, what does this do? Well, you can see on here I'm highlighted on a real weak signal, and it's barely above my noise floor at that moment. So there are several things I could do to pull that signal out of the noise. Clear up the background noise, bring up the voice frequencies. So I'm going to start off with the classic phrase in ham radio, you can't work who you don't hear. The first step in making a radio contact is to hear the other station. In a contest, you want to be able to hear someone's CQ or their answer to your CQ. And even outside of contests, if you're trying to work far away DX stations, you want to be able to pick them up out of the noise. So you hear their call sign, you can get back to them. So HF radios have many controls that affect reception. And if you look at the front panel of your radio, you're going to see a lot of acronyms. Here are a couple. And how many of you, I mean, AF, RF, everyone probably knows that, but some of the more esoteric functions. How many of you have used it? How many of you know what it does? How many of you know when and why to use it? So by the end of this presentation, you'll understand what all that means. You will know when, how, and why to adjust those options. You'll begin using your radio as more of a tool and less of an appliance. You'll gain a deeper understanding of what everything does and how you can use it to your best advantage. You may experience better HF reception. You don't have to go out and buy a new antenna. You don't have to go out and buy a new radio. Your radio probably has all this already in it. And at last but not least, your radio might sound better. You know, your wife might come over and say, are you on the phone tonight? Because she doesn't hear all the snap, crackle, and pop of the background noise. So the first control we're going to talk about is RF gain. So on the radio, it's often labeled RF. It can often be on the same knob as the volume or the AF gain. Or it can also be combined or shared with the squelch adjustment, depending on what make of radio you have. So here's a couple of examples. On the left, you see it's a dedicated knob shared with the volume. On the right side, it's a combined RF and squelch knob. So what does RF gain do? Well, it adjusts the strength of signals entering the receiver front end. And you should set it so that ambient noise on an unoccupied frequency is no longer heard. You can often use the S meter to determine what that level is. And what I mean is you open RF gain all the way up to 10, and you read your S meter to find your noise floor. Let's say on a particular band at a particular time, you have an S4 noise floor. You would start turning the RF gain knob down until your meter starts to deflect above the noise floor, and then start turning it up again until it reads just the noise floor. And, hold on, wait a second here. And yes, often you use that in conjunction with the volume to make receive audio sound pleasant. And Pleasant it's a subjective. Like, how loud do you want it? How loud do you turn it so that you don't hear the background noise, but you do hear the voice you're trying to pick out? So like I said earlier, with super heterodyne receivers, you start at the maximum and you decrease until the S meter reads just above the noise, and you increase it until you read the noise on your meter. With direct sampling SDR receivers, think IC7300, FT710, Flex radio, things of that sort, you want to start with the RF gain at the very minimum, and you increase it slightly until the S meter starts to read, and then you decrease it until no deflection. So this is real important. With a direct sampling SDR, you want to make sure you're not overloading it with excessive RF gain. Your radio has all these fancy filtering in it, but no amount of filtering can overcome an overflow of the analog digital converter. And here you can see an example of the IC7300. When it's overloaded, you clearly see an overflow indicator on the screen. And at that point, you're completely deaf. No amount of filtering will help you there. So if you ever see that light up or even flicker, you want to start by turning your RF gain down so you aren't overloading the front end. Now, next up, I'm going to talk about squelch. And most of you who've operated 2 meters probably know what the squelch knob does. It adjusts the threshold at which the speaker unmutes. And for suppressed carrier modes, like sideband, CW, RIDI, FTA, any of these data modes, it should be disabled. You don't want it to chop out the silence between transmissions, because on these modes, the sound of silence is static. Now, but for modulated carrier modes, like AM and FM, it should be set so that the speaker mutes when there is no active transmission. With carrier-based modes, the sound of silence should be silent or close to it. And certain radios have what they call voice-controlled squelch, and that claims to open when the sound signature of speech is received. And I've played with this. It sometimes works, it sometimes doesn't work, so your mileage may vary if you're doing the voice-controlled squelch. Now, next up, we're going to get into some more advanced options that you may or may not know exist on the radio that you already have, and that's noise reduction. Many radios, modern, post-1990, incorporate digital signal processors. And on these radios, you often have a button labeled NR or DNR for digital noise reduction. And what this does is the digital signal processor analyzes signals to remove random broadband noise, static, what we call QRN. There are often multiple algorithms to choose from, and unfortunately, what the algorithm number means in a lot of radios is you have 0 to 10 or 0 to 15, and usually they're sorted in increasing order of aggressiveness. Excessively aggressive noise reduction action can cause hollow sounding voices. So a couple of nights ago, I was with one of our club members, Aaron, and he was saying, "You sound very scratchy to me despite you being 10 over, 15 over." And it turned out his DSP was set way too high because previously he was trying to copy a weak signal. So you definitely want to play with the DSP setting. It's not one of those set and forget options. And ideally, you should set it to the point when the noise just starts to quiet down. Any further, and you'll also start to affect the actual voice you're trying to pick up. So we've talked about the noise reduction. It removes broadband random repetitive noise. Now, there's another thing called the noise blanker, and it's different from the noise reduction in that this eliminates short bursts of noise. Think ignition noise from your car or electric fence, making that characteristic tap, 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 tap sound. Or if the light right down your street is defective and flickering, the ballast coming on and off might cause cracks of static at a regular pace. This control is often located in close proximity to the noise reduction control, and when used in conjunction with RF gain, it can be highly effective. The options that can be set in your noise blanker include the strength of the noise burst required to activate blanking. And this is the most important option. You want to play with it so that a strong signal that is intended to be copied does not cause the radio to blank. Then you can set the duration of the blanking period. After a strong pulse of noise, how long do you want it to blank out the output? And the level of attenuation applied. Do you want it to completely go silent, or do you just want it to quiet down? Now, of course, the best way to adjust this is fine-tuning the settings in an environment with the regular noise burst. So if you're operating mobile HF, park your car off the side of the road or in a driveway or parking lot, and if you hear that noise, you adjust your settings so that the noise disappears. And remember that the noise blanker does not reduce constant noise, such as background static. That's what the noise reduction is for. And this one here, have you ever been on the radio talking and someone decides to tune up right next to you, that characteristic sound as they tune? Well, you got a notch filter in your radio, and that's exactly what it's for. It can be labeled several ways. It could be just notch, or NCH, or even NF, depending on how much paint they want to save when they built the radio. It allows you to completely eliminate a selected frequency in the audible range, such as someone tuning up on or near your frequency. Now, it's important to know that the notch filter works in the audio domain. It does absolutely nothing to stop receiver overload. And you can tell when you turn on the notch filter that the S meter reading will not change, even if you notch out that signal. So what that means is a strong enough signal, even with the notch filter, will cause the target signal to appear quiet. So if someone's tuning up at legal limit 2 blocks away, yeah, you can notch them out, but the station that you're trying to pick up probably still sounds real quiet because the radio still is getting overwhelmed by a strong input signal. And all right, so you're on your radio, you're in a contest, you got both hands on the keyboard, your foot on the foot switch, and someone tunes up on you, you got to take your hand away, right? Go to the radio, adjust the setting, change the knob on the notch filter. Well, no, that's where the automatic notch filter comes in. And this is often referred to as a beat cancellation. And what is a beat, you ask? Well, a beat is an audible tone generated as the result of 2 frequencies in close proximity. Does that sound familiar? You're on, say, 7150, someone on 7149.5 keys up. You would hear a tone 500 hertz, because the difference between your 2 tones. So the automatic notch filter identifies this tone in your passband, and it silences it automatically as if you turned on your notch filter and set your attenuation frequency. And it effectively eliminates annoying tones caused by someone tuning in your passband. And one word of importance, make sure you turn this off when you operate single sideband-based data modes, like FT8, like WinLink. Otherwise, you won't hear anything, because the radio thinks that these data tones are beats. And don't forget, CW is a digital mode. And so earlier, you probably heard me mentioning, even with a notch filter, your signal strength decreases if there's a strong enough signal in your passband. And that brings us to the automatic gain control, which is the reason why that happens. So your radio tries to maintain the loudness of audio signals regardless of signal strength. If you think of what other equipment does this, some TVs have a constant volume function, so when the commercials come up, it doesn't blow your eardrums out after you turn the volume up loud to hear what's in the movie. A lot of telephone handsets do this as well. If someone's talking loudly and someone's talking quietly, it attempts to set the level so it's constant. And so the end result of this is that you don't have to constantly reach over and adjust the volume, even though the target signal is varying in strength due to the ever-changing propagation conditions. There are 2 factors that determine how the AGC operates, and that's attack and decay time. So I'm going to talk a little bit about what that means. So if you do any music, you know that there's the ADSR envelope: attack, decay, sustain, and release. So in AGC, there's only really 2 options. That's attack, which is the rise time, how quickly the AGC reacts to an increase in signal strength. And the opposite of that, there's decay, which is fall time, how quickly the AGC reacts to a decrease in signal strength. For voice communications, the signal is directly proportional to speech pattern, and it's rapidly changing. So a slow AGC makes listening to conversations a lot more comfortable. And why is that? Your brain also has an automatic gain control, believe it or not. And it's attempting to basically normalize the amount of stimulus coming in. So if you set the AGC too fast, you leave it to your brain to compensate for the frequent changes of loudness, which people often refer to as sounding tiring, or it might even give some people a headache when the voice is real quiet and real loud and real quiet and real loud all of a sudden. For computer-operated digital modes, a fast AGC is preferable now, since the software deals with the rapid changes in signal strength. If you had set a slow AGC, like with voice, the radio might not recover fast enough when the signal drops, and what that manifests in is frequent retries as the computer tries to establish communication. For CW, AGC becomes a matter of personal preference. Some people can copy code even when the volume is changing rapidly. Others prefer a relatively constant level of loudness for a good copy. Certain radios also have an automatic AGC, which in the most simplest form, it remembers your setting per mode. Others, out of the factory, they have some optimized modes depending on whether you're operating, say, sideband or CW or data. So, in short, the automatic gain control is there to keep you from having to turn that volume knob all the time. So, what about manual gain control? Why would you ever want to disable it? Well, on most radios, you can actually disable the automatic gain control. And this has two effects. The first one is you have a greater possibility of overload now. And in superhet radios, you also lose your S-meter readout. And the reasoning for this is quite simple. It's traditionally the S-meter was just an ammeter that read AGC current. So the stronger the signal, the more the AGC needed to reduce gain, and that meter would deflect toward the right. In a direct sampling SDR, however, the S-meter always reads the RF signal strength seen by the converter, so it will continue to read even with manual gain control. You generally use manual gain control if the station you're trying to receive is in very close proximity to you, so we're mostly working ground wave. There's no propagation to worry about, so you just set the AGC to a level that's comfortable, and you just talk to them at a constant level. I'm going to say it again, as if you're talking on a telephone. So far we've covered the basics, and I'm going to just quickly go over all the settings, what they do. So the RF gain, you can think of it as you're setting the threshold between noise and signal. Squelch, you're setting the threshold between silence and audio. You use the noise reduction when you want to reduce constant background noise, and you want to use the noise blanker to reduce the effect of noise bursts. The notch filter removes beat frequencies, and the automatic gain control keeps your audio levels constant. So these controls, I believe, are on every radio you can buy these days, and some of the older tube equipment, they probably at least have an RF gain. We're going to go on to a couple of more in-depth options that, if you adjust incorrectly, can cause you to think your radio is broken. And everyone here who works at the candy store can attest to that. You get that call, my radio's broken, it's not picking anything up. And we all know what to do when that happens. So your receiver's front end is subject to a wide variety of signals, either intentional or unintentional. And that's why your radio has preamplifier and attenuator settings to increase the sensitivity and to prevent overload. And I want you to think about, what HF radio do you all have? Is it a super heterodyne type radio, or is it a direct sampling type radio? Because if you have a superhet radio, you have a mixer in the front end. And the mixer has a certain loss factor, and that's why you'd want to use a preamp to compensate for that loss. You might find that on lower bands, 160, 80, and 40, the noise floor is so high that you really don't want to use a preamp. The moment you turn on the preamp, your noise would increase along with the signal you're trying to pick up. If you have a direct sampling SDR, say a 7300 or a 710, you want the attenuator, especially if your radio is next to sources of strong RF, be it that broadcast station down the street, the ham next door, or maybe that lava lamp you really like in your room. So next up, I'm going to talk about how you can actually pick out the signal, once that you've narrowed on it. So modern mid-range and high-end receivers and transceivers have different ways of fine-tuning the passband. Cost-reduced and older radios before the DSP era used crystal filters with fixed bandwidth often that you selected. So you can change the bandwidth, but only depending on which filters you had. If you have a scope on your radio, try zooming in so that you have a closer look at the target signal. If you have no scope, you can also try to decode it by ear, and as soon as you adjust these controls, you will hear the results right away. So there are 3 approaches to bandwidth control, and I'm going to try to cover all of it, so this is going to be applicable to all of you depending on what you have. I'm going to start off with the twin passband tuning. This is often used on ICOMS radios and Xiegu radios with newer firmware. And how this works is you have 2 passbands, and where they overlap, that forms what you receive. There's usually a button to revert to the default bandwidth because it's very easy to misadjust it, and voices sound either very high-pitched, low-pitched, narrow, or you're not hearing anything at all. So here is a picture out of the user manual for a radio that I have, and you can see what it does. You essentially have 2 passbands, and in the center of the passband where they overlap, that's what you're picking up. And with these controls, you can combine them to either shift the entire passband left or right, widen or narrow the passband, or just narrow one side of it down, maybe because someone decided to start calling CQ right next to you. And of course, like I said, on the very bottom, there's a clear button to reset everything back to the defaults, just in case you find yourself misadjusting the settings. The other way of adjusting it is with a high cut and low cut, and this is used on Kenwood and Flex radio transceivers. It works very similarly to the treble and bass controls on a stereo system, but rather than a roll-off, it is a complete cutoff of signals outside the passband. And once again, this is from the user manual of another one of my radios, and it's explaining basically where you can adjust the high and low shifts to knock out noise right next to the signal that you're interested in. And here's another example of a true software-defined radio where it's operated by a computer. This one's from the Flex Radio Smart SDR user manual telling you move your mouse over the passband and just drag it left and right to adjust where your filter is. And last but not least, we have shift and width controls. And this is used on Yaesu radios and Xiegu radios with older firmware. A certain someone can attest to that. So you can either shift the entire passband, meaning you move the high cut and low cut together. Or you can adjust the width of the passband. Let's say if you're trying to pick up a signal with higher fidelity, you can widen it. If it's noisy or someone decides to key up right next to you, you can narrow it down, reduce the fidelity, but as a compromise, you're able to pick up the signal that you're intending to receive. And here's an example of it out of the Yaesu FTDX10 user manual, a real popular radio out there, explaining how you use the shift and width in combination to reject QRM. And then next up is a topic that a lot of people will find very subjective, and that's the audio equalizer. So the definition of equalizer is you want to compensate for inconsistencies in audio output devices and human hearing. Not all speakers have a flat frequency response, and so even though some people don't want to admit it, their ears no longer have a flat frequency response. So you use the equalizer to compensate for that. It emphasizes a range of frequencies, and when we're doing two-way radio, oftentimes we emphasize the human vocal range. You can also attenuate, which means to reduce, but really not completely remove background noise. And another word of importance, you should not use the equalizer for data modes, once again, because the software decoding really wants to hear equal levels of loudness on all signals. And here is an example of an audio equalizer in HF radio for the receive. As you can see, it's set to an AM broadcast station. I'm trying to pick out the voice. So I have a cut where the noise might be and a lift in the human vocal range. And with this turned on, it almost sounds as if the voice is louder. Well, it is, but I'm also cutting out some of the noise. So you hear a more natural sounding voice, almost as if they're in the room with you. And on the subject of equalizers, not to leave the CW guys out, I'm going to talk about a little function called audio peak filtering. Now, how many of you out there in the crowd work CW regularly? How many of you have used the audio peak filter in your radio? And if you haven't, I'm going to bring you to a phrase that I think captures the APF real well. And KB6NU says, somehow turning this on brings a signal right up out of the mud. And this is a pretty accurate description of what this does. It's essentially the inverse of a notch filter. Remember, the notch filter attenuates a chosen frequency. But rather than attenuate that frequency, we amplify it. And why is this useful for CW operators? Because it's a very high gain, low noise. It usually defaults to the CW pitch, essentially your BFO, beat frequency oscillator offset setting, but it can also be independently adjusted. Some of the options related to the APF is Q, which is the bandwidth, and the level of amplification on that signal. In a busy contest, you probably want to increase Q. That is, decrease your bandwidth. You want it very sharp and narrow so adjacent signals aren't amplified. But this does, however, make it harder to fine-tune the signal you're trying to receive. So if you're in a casual CW rag chew, you can increase your bandwidth a little bit, decrease the Q, so you don't have to be so precise when zeroing in on their frequency. And of course, the level of amplification on the signal. So what next? We talked about all these options. You're probably wondering, oh, that's what that button means. Well, experiment. Ham radio is all about experimentation. There's very few things that are objective. So it's band conditions, time of day, what you're listening on, what you're listening with, how your ears feel, really. Oftentimes, that might even make a difference as well. You have earwax in there. Maybe after taking out your earwax, you end up readjusting your equalizer because that one band of frequencies that you had to amplify because you weren't hearing it so well now sounds real loud. So find out what works in different situations. Your radio is really a tool, and as they always say, you got to pick the right tool for the job. And sometimes leaving a setting on, if you forget that it's on, you come back to it and conditions have changed, you might be wondering, why does everything sound so weird? Why am I not decoding this super strong signal? So with that, I'll say 7-3, and good luck in the contest, by the way. We have some questions?
All right, one of my questions is a troll question, and then one's for real. My trolling question is this. What's a better HF radio, Yaesu or ICOM or Kenwood? Flex, Anon, Hermes. Okay, that was my trolling question. I was expecting more of a rise out of all of you, but I didn't get it. You know, this is a great recording, by the way, and I want to make sure this stays on the recording because as people upgrade to general, these questions come through to the Elmer team all the time. All joking aside, though, at the different price points, and you kind of know what I mean, from QRP to entry-level radio, what would you recommend? What are like the top 3 radios as of Q4 of 2024 that one could go into? Not the candy store, because I know you work there, but any ham store or anywhere online. What 3 radios at QRP and at regular full barefoot power, what would you recommend to a new ham upgrading to general?
All right, so I'm going to start off with a disclaimer that what I'm about to say next may offend some people. And I'm being completely truthful here. There is no perfect radio, unfortunately. We hams always dream of the perfect radio. It'll pick up stations no one can hear. It'll let you score big in the contest. Heck, you might even press a button and all of a sudden that QRM from downstairs, hey, dinner's ready, will just disappear. But in truth, all right, all jokes aside, you hear people talking about how good it sounds all the time. And I liken it to how fast a car goes from 0 to 60. I can tell you this car goes from 0 to 60 in 1 second flat. You breathe on that pedal and it's taking you down the freeway. But you're not going to buy it without getting into it, are you? wow, how does it feel? What is the interface like? Is it comfortable? Are you crammed in there, or are you truly in your comfort zone? And with radios, it's really the same thing. So you have radios like the FTDX10 from Yaesu with an excellent receiver. Multiple tests have shown that it is very sensitive, and there's so many filtering options. However, just like that car that goes real fast, you might be crammed up in there. The user interface leaves a lot to be desired. And that's where the ICOM 7300 comes in. Yes, it is an older radio. Yes, it does have a slower digital signal processor. But the user interface, really, in my opinion, is to die for. And if you know what you're going to use the radio for, if you're in a suburban or rural environment with not a lot of interference around you, and you don't plan on taking it to contests where there's a guy operating 100 watts or more right next to you, it's still a great choice. Just because it's old doesn't mean you have to just immediately look aside. And well, for QRP, really, there's only, as of this presentation, there really is only one player in the game. That's ICOM with their 705. However, that is about to change. For any of you who follow the latest releases, Yaesu is coming out with a new QRP radio, the FTX1F. Take a look at the spec sheet. I think you'll be surprised at what new technology can do. But other than that, it's a matter of personal preference. I mean, there's things that are sold not by dealers, but by the actual manufacturer themselves. Flex Radio, Elecraft come to mind. So definitely go out there and test drive these radios if you can. If you can go into a brick and mortar store and sit down and operate it, great. If it's an Elecraft or a Flex, find someone who has one and maybe will let you test drive theirs. You might find it to be just your type. So really, in short, there is no perfect radio. Go out there and once again experiment. Find out what fits best for you. We got another question from the audience.
I just wanted to add into what Jim said in trying on some of these different radios and stuff like that. One of the best ways to do that is coming up next month, and that's Pacificon. They're going to have representation there from Flex Radio and some of the other radio manufacturers and stuff like that. So that would be an excellent opportunity to be able to ask questions and to be able to try out the radios.
That's absolutely correct. All the manufacturers will have their big rigs out there. I don't believe ICOM will have the 7851 on display this year, though. That's been discontinued. But for a lot of us, that was our one chance to actually touch the real thing.
Maybe the 7760, though.
Possibly, if it's ready for production and has FCC improvement.
Any more questions?
Any other questions? Going once? Going twice? Well, thank you all for attending, and I hope this presentation was useful. And what I really hope is that possibly tonight or tomorrow night, as long as it's not the day of the California QSO Party, to go home and start pressing buttons and turning knobs on your radio. And, you know, if all else fails, there is the factory reset button. Just saying. But anyhow, yeah, definitely experiment and find out what all those functions do. You'll be real surprised.
All right, thank you, Jim. Let's give him a big round of applause.